I've had a number of viewer questions, both on my YouTube channel, on the Facebook page, and on Twitter. And I'll put links to get to all of those down below. Mostly about the Esp8266, but a couple of other things. So first on Bounce, I've gotten the WS2812 lights, working with it, and I demoed this week a little bit at the London Arduino group after the main sessions in the breakouts. And I'm going to be also demonstrating this further this weekend at the Ham Coder Dojo, where Helena, my lab helper, will be going to do some Raspberry Pi learning. Bounce has now been released at 0.2.1, which includes revised support for this. It includes a number of fixes, including what happens when serial ports are a bit iffy, things about new document and so on. Okay, so questions. So the first question I had today was from Shashi Kiran, and he was asking about, would the NodeMcu, the Esp8266, work with a servo motor, or can I demonstrate it doing so? So first I'm going to connect up a set of batteries, so I've got 6 volts to play with. Servo motors, they need a bit more than the 3 volts you're going to get out. We don't need anything further in the way to voltage convert, and I'm just going to use this little assembly for a distance sensor for a robot. So I'm going to hook this up. This is all completely off the cuff, completely unrehearsed, so let's see where we get to. So I'll just go and connect this in here. I've got a ground down here. I've got a data pin here. The yellow pin on the servo is data, and we'll say, I don't know, let's take a random pin. Let's take D2, jump something across for voltage. So first thing I'll say is, for circuits like this, I'll use fritzing to put a circuit diagram of what I've done online, so you can follow it, and I'll also make sure that there's some code available too. Okay, let's hook up ESP first to my laptop, and for this I'm just going to use Explorer, which I've been using now quite a lot to interact with the ESP. A nice Lua IDE with a serial interface. So the NodeMcu API, there's a reference to it, which lists all of the commands, all of the various bits you can use, all of the ways it can be built. Okay, so the first thing I can say is they do not have a servo module. I don't believe that's much of a problem, because I think we can do this with straight PWM. So for those who don't know what PWM is, pulse width modulation, where you've got an on time and an off time, so high and low, and you are varying the amount of on time in relation to off time at the same frequency, and this changes where the servo will actually position itself. So let's see if we can get that up and moving. The other thing I'm going to need is to add the remaining battery in. I always ship it with one battery not put in the system, so there's nothing live until I want to go. Right, so the first thing we see there is that servo is now powered up and active, because you saw it just tweak and move a little there. GPIO.mode pin 2, GPIO.output, PWM.setup pin 2. So what do we do with PWM setup? Clock and duty. 50 Hertz, and we'll say 500. Nothing happened there. The motor is on. Oh, PWM start. Right, nothing starts until you issue PWM start, according to the docs. Ah, that did something. Let's try that. Oh. So that's gone on full lock on one side. Let's do that. I think we might be able to just do set duty and move this motor. So if I do that, there we go. Okay, and if I then do it the other way up, let's do snap in the middle. Certainly we're getting a useful function out of this. So I suppose one thing I might have to do is bring this together with one of my other robots, maybe set this particular module on top if I can actually get it to do this ping module, and these are a bit trickier because they require some precise timing. But we've certainly demonstrated that we can get the servo moving with NodeMcu control. And if you combine that with the stuff we did, the LEDs, you could probably get it so you can move servos, multiple servos, via some kind of web interface, via Wi-Fi or something. Okay, so I'm hoping that for Shashi that answers your question. I'll have the code that I've used alongside the circuit diagram as well. And let's see what the next question was. I'll just disconnect those batteries for that poor thing before they die. So another question I had that was slightly unusual from a chap called Goodwill was any recommendations or reviews for AC power supplies on eBay. I think, to be honest, that's probably not the best idea. Now, every power supply is different, depends who the manufacturer is, depends if it's a genuine one. I use a lot of USB power supplies just for 5 volts. I've also got some of the very kind of basic multi-voltage power supplies that you can pick up from a local Maplin or other electrical store. If you're replacing a specific laptop power supply, eBay may be a place to get it. Just be aware that they can be very varied in quality and safety. There was quite an interesting recent podcast in the Solid podcast by O'Reilly about power supplies and about the difference between very cheap ones and very decent ones. So while I haven't had a lot of experience rooting around the inside of them, I would recommend you understand exactly what you're getting into. If you're buying a general lab supply, you either go for something very serious, in which case you pay for what you expect. If you're going for something cheaper, get something from your local Maplin. It's going to be a lot safer than some cheap thing on eBay or Banggood. It's not one of the things you want to get the cheapest thing of because there's a safety factor in it. Okay, so the next question was from Joe Dyer, who was playing with Bounce and wanted to find out about flashing the NodeMcu with Windows. For this, I recommend the GitHub project NodeMcu Flasher. So NodeMcu Flasher has got Windows binaries bundled with them a relatively recent NodeMcu release. And that one you can point other binaries at it. Start the NodeMcu Flasher software up. Holding down the flash button, plug your NodeMcu in and hit the flash button on the software. And that will pick it up and flash firmware to it. One little gotcha is that they switched the default baud rate from 9600 to 115200. So you may have to tinker with that. I'm yet to add a good UI element to Bounce for switching baud rate. At the moment it's expecting 9600 based on the old firmware. I'll put links to the NodeMcu Flasher project. Another viewer via Facebook, a chap called Leroy Mail, I'm sorry, I'm probably pronouncing it horribly, has been doing stuff with the WS2801 array, and he's been telling me about his exploits with that, and he's been using the Adafruit Feather Hussar, which is another Esp8266 board, and he had a bit of trouble getting this to work. Now it's kind of like the WS2812 LEDs. So here we are, let's have a look at these. So if you look at the WS2812, the LEDs integrate their control circuitry. This is the 2801s, freshly from this bag, and these have come straight over from China on a nice spool. So this strip, it's a flexible strip. So first thing to know about these is, if you've been following stuff on the 2812, they are a 1-pin protocol where there are 3 pins coming out: power, ground and signal, and you send data straight down the signal with the clocking on board. With the 2801, there are 4 cables going in, and that's a power, ground, clock and signal. So you have to do both. The other thing is, if you look at each segment, you've got your RGB LED, which is going to be PWM controlled, and each one has got a little microcontroller next to it to decode those clock and signal lines. It daisy chains along the same way that the 2812 does, but again, they predate the 2812s. So let's see if I can get this to light up. And this might take more than just a short explanation, but let's see if we can have a bit of fun and get it to do something. Let's lay that out, and let's find out which side is input and which side is output. Aha! There is a handy little arrow on each of those LEDs saying which way it goes. So that's got to be the output side and there's got to be the input. Let's just watch where those trailing wires end up. Do we have a WS2801 library? Of course we do. Okay, well that makes things easy, so we can use the library in NodeMcu. There might be an Arduino library for this as well. If there's a NodeMcu library, I can eventually add bounce support. We have red and black, which is going to be positive and ground, or live and ground. I'm hoping I can hold that at the 6 volts. And one of these is going to be data and one of these is going to be clock. Each of these has actually got which pin printed on them, in which case we have voltage, clock in, data in, ground. I'm not going to tin them now, but if I was doing this properly, I would tin them. So we have something going to a ground pin. We have something going to a voltage pin. Then we can pick up 2 I/O pins. So let's use pins 3 and 4. We can do WS2801 .init, and we give it a clock pin and a data pin. So its clock is 4, data is 3. WS2801 right. So we use the same string.char. So RGB. Nothing has happened yet. Just swap those clock and data lines in case that was wrong. Okay, one of the first rules of debugging electronics: thou shalt measure voltages. So let's see what's going on. Let's make sure we're actually getting power, because I've got those horrible multi-core connections anyway, and they're not going to be great, to that board. So if I take one of these to ground and the other one to the V plus up here, and I'm getting about 4.5 volts. Okay, so let's disconnect the servo. Let's see if we're getting something slightly better, but it sounds like these batteries are low anyway. I've got about 5 volts now. Okay, let's try and send that line again. Nothing, no lights. Leroy, it looks like I am replicating your result with the NodeMcu software. I carried on doing some experiments offline and thought I'd add an extra segment showing how I did get them working. So there were a number of problems with the setup I had earlier. The first one was that I wasn't really getting the greatest of contact with these multi-core wires and a breadboard. So I'm using this slightly larger, slightly more super-powered breadboard, which has got some nice big screw terminals, which means I can get a good solid contact. I might try and see if I can get some of those breadboard wings, you know, the ones that give you a set of screw terminals attached to a breadboard, any breadboard, so I can use it with the smaller ones. But this one will do. And because they're color coded, I can use the same color scheme. And let's get some batteries into play. So I made the light strip actually do stuff last night. It turns out that beyond the contact questions, which needed to be addressed, the other real issue was to do with the way I was addressing the pins. So on the NodeMcu, the usual standard of things that it works to are that the NodeMcu pins and the GPIO pins are mapped. So NodeMcu numbers are mapped to the D0 on the board, will be 0 in NodeMcu. However, with a slightly surprising lack of consistency, unfortunately, the WS2801 module expects you to put in the GPIO pin numbers and only works on certain GPIO pins at that. What comes here as D3, D4, which I believe are GPIO 0 and 2, you have to put in the 0 and 2, not the 3 and 4. And the reason it might confuse people trying to get the WS2801 working with it is it doesn't obey the same mapping standard as the other pins. Right, let's go and get some code running on this. Right, there we go. We have green. We have blue. Well, anyway, I thought I'd share with you that I did get this working and how I got this working. And we'll go back to the original video. I'll probably next week be doing more video on Bounce, showing some of the new things I've done with it. Perhaps I'll try and get the servo motor running in Bounce, which would be fun. And I'll also perhaps demonstrate some more with these robots with Bounce. I'll see you on my next video. If you like this, please give me a thumbs up. Please subscribe and leave comments below if you've got anything you want to say, including asking me more questions, because I'm sure I'll do another video with a bit of Q&A answering some of the questions people have asked me. All right, good night and see you next time. Bye.